Hi, this is Dr. Thomas again, and today I would like to talk to you about the difference of squares. And hopefully by the end of this session, you will understand how to recognize the difference of squares and how to factor the difference of squares. How do you recognize when you're dealing with a difference of squares factoring problem? Well, first, are you dealing with a binomial? Binomial meaning two terms. Is there a minus sign in the problem? Usually the minus sign is in the middle. And can you find the square root of both terms? So it's important also that you understand that difference means subtraction. So therefore you see a minus sign. And also, if you can find the square root of both terms, those terms are called perfect squares. Hence the term difference of squares. You should always factor out the GCF first. So if you see that there's a common factor among the binomial, you need to factor it out first before you do anything. And you should always classify an expression as not factorable if it is a sum of squares. Sum refers to addition or the plus sign. So the sum of squares is not factorable, but the difference of squares is. The difference of squares, it looks like this. You have a squared minus b squared. It is a binomial. It has a minus sign in the middle, and you can find the square root of both a squared and b squared. So these are considered perfect squares. The square root of a squared is a. That's why they have an a in these two positions. And the square root of b squared is b. That's why they have a b in these positions. And the signs will always be opposite each other. So you can write it as a plus b times a minus b, or a minus b times a plus b. The order does not matter. If you would FOIL this, you would prove that these are the factors to a squared minus b squared, because once you FOIL it, your middle terms will cancel out. So let's prove that. So we said that a squared minus b squared factors into a plus b times a minus b. Proof. Since multiplication is the reverse of factoring, all we have to do is multiply a plus b times a minus b to prove to us that these are the factors to a squared minus b squared. Remember that factors are just the product of a term. So a plus b times a minus b. A times a is a squared. So now people refer to this as the FOIL method, but it's also considered the distributive property. So we multiply a times everything in the second parenthesis. We get a times negative b would be negative ab. Then we turn around and multiply b times everything in the second parenthesis. So that's plus ab, and then b times a negative b is a negative b squared. Negative and minus, we use it interchangeably. Means the same thing. Alright. Notice that the negative ab plus ab, same term, different signs, so you subtract. So the middle terms cancel. Therefore we have just proven that a plus b minus a plus b times a minus b is a squared minus b squared. Alright, let's get started. We're going to factor the following. Let's factor first x squared minus 9. You first have to determine if you have a greatest common factor. You do not. There's nothing in common with x squared and 9. Since it's two terms, you realize that it could be a difference of squares. It's two terms, it has a minus sign in the middle, and yes, you have perfect squares here, since you can find the square root of x squared and you can find the square root of 9. Go ahead and put your two parentheses, because you know it's always going to be two parentheses if it's a difference of squares. The square root of x squared is x, so go ahead and put x. The square root of 9 is 3, so you put your 3 here. And the signs will always be opposite, so it does not matter the order, but you just need to make sure that it's a plus and a minus somewhere. We're done with A. Let's go to another problem. Let's try 9a squared minus 16. First, the GCF. Always take the GCF out first. It does not have one. Since it's two terms, maybe it's a difference of squares. It happens to be a difference of squares. So we're going to put our two parentheses. The square root of 9a squared is 3a, because 3a times 3a is 9a squared. The square root of 16 is 4, because 4 times 4 is 16. Then we're going to put a plus and a minus sign, or minus plus. Done. Moving on to the next problem. Let's try r squared minus 100. Again, no GCF. No GCF, but it is a difference of squares. And by the way, if it seems I'm going too fast, you could pause the tape. If it seems like I'm going too slow, you can speed me up. So this is the beauty of integrity. You can pause and work the problem out before I work it out, and that may help you. So that's a tip for you. Alright, the square root of r squared is r. And the square root of 100 is 10, because 10 times 10 is 100. Plus, minus. I put a check mark before I even did the problem. I'm very confident, I guess. Alright, let's do one more like so. Let's try 49 x squared minus 1. No GCF. Therefore, let's determine if it's a difference of squares. It is. Put our parentheses. Square root of 49x squared, 7x. Square root of 1, because 1 times 1 is 1. Plus, minus, look back at it. Done all that you could do. Move on. Alright, let's continue to factor. Let's try this one. 2x squared minus 50. Alright. Does it have a GCF? Yes, it does. What's in common with 2x squared and 50? It is 2. So you need to take that 2 out first, because it's the greatest common factor. 2 times what will give you back the 2x squared? The x squared. 2 times what will give you that minus 50? That minus, or that negative 25. And see what emerges here? A difference of squares. Therefore, you have not factored completely just yet. So if you see that expression, factor completely, it means you need to factor until you can't factor anymore. So let's continue. Do I throw away this 2? No, do not throw it away. It is a part of your factor. So you need to write down 2 again. So don't throw away factors. You won't get back what you started with. But we expand that x squared minus 25 into its factors. Since it's a difference of squares, we know to put x here, because the square root of x squared is x. And the square root of 25 is 5. Then we put plus minus. Look back at our answer. Can't do anything else. We're done. Let's try one more. B. Let's factor x squared plus 36. GCF? No GCF. Is it a difference of squares? No, it is not. Why isn't it a difference of squares? Because there is a plus sign in the middle. Since there is a plus sign in the middle, it is a sum of squares, and we've learned that a sum of squares is not factorable. So if you see this in your homework or on the test, you can just put NF for not factorable or write it out as not factorable. Alright, so maybe you are wondering why it's not factorable. So I need to explain that. If you already understand why it's not factorable, you can forward past this part. Okay, so let's just try something that you may think are the factors. Possibly the factors could be x plus 6 times x plus 6. Sounds good, but once you multiply this to prove that these are the factors, you will realize that they are not the factors. Since, let's do the distributive property of 4 method, x times x is x squared. X times 6 is 6x. 6 times x, 6x again. 6 times 6, 36. Alright, so we do have that x squared and that 36. However, we have a whole middle term right here. 6x plus 6x. So really, these factors were the factors to x squared plus 12x plus 36. Not the factors to x squared plus 36. So therefore, we're proving that x plus 6 times x plus 6, those factors are not factors for x squared plus 36, the sum of squares. So we rule this as not factorable. Okay, maybe one last problem. Let's try to factor, and of course all of these are factoring problems. I guess I'll have to write it over and over and over again, but if you see factor, make sure you factor and don't multiply. That's what I want to get across to you. Multiplication is the reverse of factoring. Okay, here the first step to factoring is always GCF, GCF, GCF. I can't express it enough. So the GCF here is AB. So notice that there's an A in both terms. There's one A here, 3 A's here, but the highest number that I can pull out of both of them is only 1A, because I can't pull more than 1A out of AB. So we need to take the A out, and also a B is in both terms. So we first take that out, put one set of parentheses, and then we say AB times what would give me back that A cubed B. Alright, we have 1A, we only need 2 more A's, so A squared. A squared. We already have a B, so we don't need to put a B here. Minus AB times what would give me back that AB? Just 1. Just 1. AB times 1 is AB. So you should be able to multiply this to get back what you started with. If you do not, then you have not factored correctly. Alright, what emerges here? A difference of squares. Therefore, we have not factored completely just yet. Bring down that AB. Do not leave it, or else you have not factored completely. Alright, the square root of a squared is a, and the square root of 1 is 1. So put a plus and a minus, or a minus plus, and this is your answer, AB times a plus 1 times a minus 1. Okay, that concludes the session on difference of squares. I hope by now you know how to determine if an expression is a difference of squares. It needs to be a binomial, a minus sign in the middle, and you should be dealing with perfect squares, or you can find the square root of both terms. Always remember to take the GCF out first, and if you see a plus sign, it could be a sum of squares. So make sure you put not factorable if it's a sum of squares, but if it is a difference of squares, to factor it. Alright, until the next time, bye.